Hey everybody, it's Miss Phoebus again, and this is Lesson 15, Set and Interval Notation. Now, along with this video, there's going to be another video that I'd like you to watch. It is more of a fun video. It's something that I do show in class. I will tell you, do not fall in love with the animals. They have big, cute eyes, but they are getting processed in a factory. But it is something that I do like to show, and I would like to share that with you so that you can see it. So that will be underneath this video. So set and interval notation is something that I'm going to introduce to you. You actually already have been exposed to set notation and doing our inequalities. But interval notation is something that we're going to end up using a lot, and you need to be able to go back and forth between the two. So this is a lot of learning how to read it, looking for special symbols, making sure when you write things you're using the correct symbols, and that kind of stuff. All right, so on a sheet of notebook paper, make a two-column table, words I know and words I don't know, and here are your words. Set notation and interval notation. Do you know them or do you not know them? Pause the video, figure it out. All right, interval notation is a notation for representing an interval as a pair of numbers. And so all you have are two numbers. You could possibly have more numbers depending on what the, in this case we're using it for domain and range, what those values are. But the numbers are the endpoints of the interval. We use parentheses and or brackets to show whether we are including or excluding those endpoints. Set notation is a different kind of notation, still representing an interval, but this type of notation uses inequalities for the interval. Okay, so your goal today, by the end of the video, is to be able to identify domain and range of functions on the coordinate plane, not so much, but be able to write those things. So like writing the domain or like writing the range. We're going to get more into that. So we're going to relate the domain of a function to its graph, and where applicable, the quantitative relationship it describes. So when we're talking about domain of a graph, it's not only of a graph, but when we talk about domain, we are looking at how can we talk about it, how can we relate it to something, and so we have to be able to notate that. So set notation uses inequality. Sometimes it's called set builder notation. Sometimes it's called inequality notation. Just kind of depends on who's talking about it. But it uses inequalities. Interval notation uses symbols to notate range. You must be able to read this domain and range in interval notation. So here we go. Our interval notation. Now this one, really, I would call, this is our set notation. And then this column over here is our interval notation. And they're actually saying the same thing. So you are familiar with all of these symbols that we've been working with because we've been working with them. These are, remember, our compound inequalities. Here are our ands. And then we have some of these that we've been using. These are our regular inequalities. Okay, or you could put two of them together using the word or. You could do that. And then, of course, we've got negative infinity to positive infinity. So that implies for this one, all real numbers, which implies the whole number line. Okay, so all of those, when we look at these, and let me go ahead and just show you how to read. We need to go back and write some of that down. You can pause it. So this is saying right here, this is saying that x, all of our values, are between a and b, including a and b because it has those equal to bars. Then the next one is x. We are looking at all the values between a and b, but only including a. We're not including b. And now if you look at this one, This one says we're looking at x, all the values between a and b, not including a, but we are including b because we're equal to b. For this one, we have all of our values being greater than or equal to a. For this one, all of our values are less than or equal to a. For this one, x is greater than a. And this one, all of our values are less than a. So those ones that I just talked about are pretty straightforward. Usually, it depends on what you're looking at, what graph, what number line. Will determine what pieces. So the question is endpoints. Do you have 2 endpoints? Or do you have 1 endpoint? Now, if you only have 1 endpoint, that implies, so let's think number line style. Let's say I have 4 here. I have an open circle. I'm shading to the right, all the way to the right. Make sure when you shade, you're shading on the line. You have your circles there on the line. You're shading all the way to the arrow. Some of you I've had to give a little bit of instruction for. But the question is, I have 1 endpoint, in this case 4. 4 is the smallest number that I can use, but not exactly 4. And then what is the largest? What is the largest number that I'm allowed to use when I say all my answers are between 4 and what? So as I go to the right on a number line, the biggest number that I can possibly reach is infinity. And infinity looks like a sideways 8 taking a nap. All right, but the thing is that infinity isn't really a number. Infinity is a man-made idea. So when we talk about in the interval notation, do I use parentheses or brackets? We have to, when we deal with infinities, we'll talk about, actually, here it is. Infinity always gets a parenthesis. Okay, so if you're dealing with the largest number, no endpoint, you're going to use an infinity. Well, what happens? Let me change colors. What happens? So now we're just going to look at the blue. If I go to the left, and I say, okay, starting at 4 and going to the left forever. Well, what would that imply as being one of our endpoints is 4. What is the smallest number? Smallest number on my number line. And so all the negative numbers are out here, so you actually have a negative infinity all the way to the left. Again, it's a man-made concept. There's not an actual infinity or negative infinity. It just implies that there are very, very large and very, very small numbers. So when I am talking about interval notation, I'm still talking about endpoints, but I'm really focusing on what those endpoints are. So if you notice, erase this, because I'm going to start comparing the two. If you notice on all of these, they have an A and a B because the smallest value is A, the largest value is B. Smallest value is A, largest value is B. And it's in order. Smallest is on the left, the largest is on the right. Now, oops, went a little too far because those have 2 endpoints. Okay. And then when you pick up 1 endpoint, so A, notice that A is in here. But also we have infinities. So we have infinity, this is going to the right. So we're looking at starting at A and going to the right, and that's what this inequality says. Start at A, we're looking at everything greater than or equal to A, shade to the right. This one, because the negative infinity is on the left, that means it's going forever on the left side, shaded to the left, and then the rightmost point is A. That's why it's written on the right. Okay, so that's what we're practicing. We're practicing, well, how do you write the endpoints? What are the endpoints? How do I write them? And then if you notice, we have some different notations. So I have some over here. You have where you can have brackets. These are little square brackets. And if you look on your Chromebook, you actually have them. They're right below the curly braces, so you don't have to hit shift. So they're next to P. The P on your on your keyboard. Okay, so you don't have to hit shift for those. So that would mean that I include a value. So I use a bracket when I include a value. I use a parenthesis when I don't include a value. So these parentheses are like having an open circle, and then the brackets are like having a closed circle. And you're going to get used to when do you use what. And how are you going to get used to it? You're going to practice it. And you're going to go back and you're going to read the feedback that I give you on your homework, and you're going to try to learn from those mistakes and get better. All right, but infinity and negative infinity always have a parenthesis because you can't ever actually get to infinity or negative infinity. So we're going to practice reading. We're going to practice writing some of these. All right, so we're going to start in word form. We're going to get this into our set notation, which is something we're familiar with. We're going to actually kind of skip down. We're going to draw it on the number line, and then we'll do the interval notation. And we'll compare, and that's the reason why they're together, we'll compare the set and the interval notation. So I really highly recommend you make a table like this in your notes so that you can go back and you can look at it later. So pause the video if you need to do that. All right, I'm going to go ahead and jump in. So real numbers and all of these, all the numbers you have ever worked with and will continue to work with until you get to Algebra 2, every single one of them are real numbers. So you get into Algebra 2 and then they start introducing things that aren't real. So every single thing that you are dealing with, we're gonna use x. X is going to represent a real number. So we're looking at real numbers greater than 2. So I'm going to have, there's my x, that's going to represent my real numbers, greater than 2. Now, I want you to go ahead and on a number line, that is a terrible number line, let's try that again. On a number line, I want you to get that graph down. You should have 2 with an open circle shaded to the right. Okay, so all about interval notation is all about endpoints. So we have a smallest endpoint. We write that first. 2 is our smallest endpoint, and we always put a comma between our smallest and our largest to show, this is the end. We've said what our smallest is, comma. Now let's say what our largest is. It's always smallest, comma, largest. I have people that do largest, comma, smallest, and I have to fuss at them, and I don't want that to be used. So smallest, comma, largest. Now the largest number in this shaded region goes all the way out to the right, so it's infinity, and you're going to be practicing your infinities. Sometimes they're good, sometimes they get a little crazy. Sometimes I draw my infinities like this because they're not looking too hard. But practice your infinities. Now comes the bracket parenthesis choices, okay? So because we have an infinity, infinity always gets a parenthesis. Because 2 is an open circle, it doesn't have an equal to bar, it gets a parenthesis because you can't be at 2 exactly in this set of answers. You can be at 2.000000001, slightly larger than 2, but you cannot be at 2 exactly. A bracket, a square bracket, is going to imply, yes, my number right here, I can use that. I can touch it. It's part of the answer. All right, so if you notice, x is greater than 2. 2 is my endpoint. 2 is the smallest value that would fit with, not 2 exactly because we don't have an equal to bar, but 2, it gets into that parenthesis. And then we go off to infinity because, not like a sideways 18, but we go off to infinity because we're looking at all the numbers bigger than 2. And a million's bigger than 2. 250,000 is bigger than 2. We have lots of numbers that are bigger than 2. All right, so let's look at the next one. Real numbers between -5 and 3. 3 is not included. So we're going to say that if they're telling us 3 is not included, we're going to think -5 is. Now, some of you may have trouble with the inequality part, but I think we could get a graph on there. So let's try that. All right, so we have -5 is our smallest, 3 is our largest. 3 is not included, it gets a circle, but 5 is included, it gets a closed circle. Sorry, I forgot the word there for a second. And then we're looking at all the numbers in between. So we're looking at all the shaded region in between that. Okay? So when we go to write our inequality notation, our x is in the middle because our shading is in the middle. We have less thans. They're always less thans, unless you have like this or compound inequality thing going on. Then you can turn them into greater thans. You should never have them pointing in different directions because that's confusing, and probably they need to be separated with an or in between them. But this is an and compound inequality. Now, for the -5, I'm going to put an equal sign underneath that because it is a closed circle. -5 is the smallest. So notice that -5 here is on the left, so I make sure -5 is on the left. 3 is on the right, so I'm going to make sure 3 is on the right. So -5 is less than or equal to x is less than 3. All right, now we're going to focus for our interval notation just on the endpoints. The smallest number in my answer, my shaded region, is -5, comma, the largest value is 3. All right, now, open circles get parentheses. 3 has an open circle, so it gets a parenthesis, meaning that we can't be at 3 exactly, but we can be close to 3. We can be at 2.9999999999999 and be in the answer, but as soon as we roll over to 3, it's like, nope, you're out of here. All right? But because we have an equal to bar at our -5, we have a closed circle, we put the square bracket, and there is a definite difference. Okay? That's your interval notation. It's all about endpoints. Where is the smallest endpoint? Where is the largest endpoint? All right, real numbers less than 4, or, ooh, we have an or here, greater than or equal to 10. So let's get that on a number line. My two numbers on the number line are 4 is on the left, and 10 on the right. Less than 4 would mean that there is no equal to bar. That means open circle, less than 4, shade to the left. And then greater than or equal to 10 means closed circle, and greater than is to the right. So definitely an or. Definitely see an or there. When I write this, I want to write or. Some of you are trying to get a little creative, which I appreciate, and you're not wrong, but you're making it a little bit more complicated than it should be. Just saying. I think if you make it too complicated, you might confuse yourself. So I don't want you to get confused. Remember, we're using x, so we want numbers less than 4, so x less than 4, or, and then we have to bring x back into it, so you gotta write x 2 times with an or like this, greater than or equal to 10. Now, with our interval notation, we have a new symbol, a brand new symbol that I'm going to introduce to you to represent or. But before we do that, what we're going to do is we're going to write each one using our interval notation, and we're just going to leave a space, and then we'll talk about what we're going to put in for the or in just a minute. Okay, so let's think about the one on the left. The x is less than 4. Again, it's all about endpoints. So the smallest value, and if you would be in the classroom, you would see me wildly, not wildly, but waving my arm, pointing to the left side of the room, out the door, down to the football field, and past. What is the smallest number on that number line? It is -infinity. Comma. And we're only going up to 4. Remember, we're doing this in sections. So all the way up to 4. Now, -infinity gets a parenthesis because it's an infinity. And then 4 also gets a parenthesis because it's an open circle. So that is this x is less than 4. That is the interval notation to show all the numbers that are in the answer from -infinity all the way up to 4. Right? Let's look at x is greater than or equal to 10. So the smallest value is 10, because that's on that right side. If I'm just focused on this shading right here, the smallest value is 10. And then the largest value, I'm going to go to the right forever, So I'm going to go to positive infinity. Now infinity gets a parenthesis, but because 10 has a closed circle, it gets a bracket. All right, now here is your new symbol. We have to join these together. Okay, these are two separate interval notations, two separate parts of the, we can go ahead and say parts of the domain or parts of the range or something like that. But we want to join them together because they're part of the same problem. They're an answer to what's going on in this graph. So I have to join them together. So I'm going to make a capital U. And that capital U is actually a special curve. It's not really a capital U, but if you use a capital U, I understand what you're meaning. But that U stands for union. And what we just did was we taped these two pieces together, two different domains, and we joined them together and they got married. Dun, dun, da, da, dun, dun, da, da. We unioned them together to create one new answer. Okay, so it's like they were two separate pieces. Just like when you get married, you're two separate people, and then you come together and you make one family. This is coming together to make one answer. So that is what that capital U represents, union. Okay, it doesn't happen too often, but it does happen with your ORs where you have pieces that you have to kind of stitch together. All right, so here we have some problems, and what we have is we have one of each, and what we're going to do is we're going to decipher some stuff. Now, on this one, there's no shading because I like to add the shading. I love to shade. And then we'll get into some other ones. So you can copy the table down. You can just do, make a list. But if you want to pause the video and see what you can do, you can do that. If you want to follow along with me, we can also do that. But I'm going to do one. I'm going to do both of those to get the blank parts filled in. All right, so on number one, x is greater than 5. That's going to be pretty straightforward. We've been doing that for a while. We have an open circle because that's a greater than, and we're going to shade to the right, all the way down to the right. All right, the interval notation, the smallest value in my shading is 5. But I do not include the 5 because it's an open circle, so it gets a parenthesis. Comma, the largest value in my shaded region on my number line is positive infinity. It also gets a parenthesis because infinity is an idea. You can approach infinity, but you can't ever actually get there. Number one, done. How'd you do? All right, let's look at number two. Number two, I have a number line. So I'm going to fill that in, and I'm going to have x is, and then for my shading, I'm going to have less than or equal to 4. All right, so the smallest number in my shaded region, if I go to the left forever, I'm at negative infinity. And because it's an infinity, it gets a parenthesis. Comma, now I want the largest value. So if I go all the way right on my number line, looks like it stops at 4. 4 has a closed circle. Closed circle gets a bracket. All right, number 3, these guys are parentheses. It's kind of hard to tell a little bit because of the way that the computer typed them. But if I was going to graph this on a number line, looks like the number on the left would be negative 10. The number on the right would be negative 3. Because they are both parentheses, they are both open circles. And because those are my endpoints, I am shading everything in the middle. Now, if you already completed this and you thought they look like brackets, then the only difference would be that your circles would be filled in. And so that's kind of how you interpreted some bad writing, some bad font, and that's okay. That's on me and the computer. All right, let's get this in set notation and equality notation. So negative 10 is the smallest, negative 3 is the biggest, x is in the middle, and then your inequalities are always going to point to the left. They're always going to be less than. If you decided to call them brackets, then you might have some equal to bars in these. All right, let's look at 4. Number line. -5 is on the left, 2 is on the right. -5 looks like it has an open circle, 2 has a closed circle, and then x is between those two, so our answers are between those two numbers. So those are our two endpoints. So then now when I write my, it's not an order pair, like number 3 looks like an order pair, it's not an order pair. So don't think of it as an order pair, think of it as your interval notation. Where does it start, where does it end? So -5 is where it starts, that's the smallest value. It has an open circle, it gets a parenthesis. Comma, the largest value, the furthest right you can go is 2. It does not have an open circle, it has a closed circle, so it gets a bracket because it has an equal to bar. If you can point to it on the number line and it's got a closed value or it's a shaded value, it is completely whole, it is going to have a bracket. Right. In this part, I definitely would like you to try it on your own. See if you can do 5, 6, 7, and 8, and then we'll come back. Ooh, let me do this one. Shading. Okay, now you can pause the video, come back, and we'll check ourselves. All right, so in number 5, we have a number line. We definitely have an OR compound inequality. I'm going to write OR. And then I'm going to use x. So on the left side, I'm just going to focus on this left side first. I have everything less than or equal to -2. And then let's do the right side next. I have, and I need x again. So for an OR, you need 2 x's. I have greater than or equal to 5. Okay, so this is one that we did in those first 3, where because we have OR, we have to marry them. We have to union them with that big capital U, that new symbol that you're learning, in addition to when do you use parentheses and brackets. So we're going to I'm going to go ahead and put my U in. That's what I like to do. But for number 5, for the left part, the x is less than or equal to -2. I'm going to have the smallest value be -infinity, comma, and then it gets a parenthesis with the -infinity, because infinities always get parentheses, all the way up to -2. -2 is the largest, and it gets a bracket. All right, now we're going to jump to the other side, and when we jump to the other side of the OR, we're going to jump to the right-hand piece. And if I think about that, or if I think about the number line, the smallest value that I can use in my answer, my shaded answer, is 5. It gets a bracket because there is an equal to bar, or there is a closed circle there. If I shade all the way to the right, what number is all the way to the right? Positive infinity. So comma, positive infinity, and infinity gets a parenthesis. Oh, looky here. There's another union. So that means we have another OR compound inequality. Now in this one, you can kind of tell the difference between the bracket and the parentheses. So there's a bracket here, and then there's parentheses everywhere else. Easier when you can have it to compare it to something. So let's get this on a number line. Can you tell what numbers are on that number line? I see -3 and I see 0. All right, -3, you see that little bracket right there with the -3? That means closed circle. And with the 0, we have a parenthesis, that means open circle. From -3, we're going to -infinity, so we're shading all the way to the left. And then for 0, we're shading all the way up to positive infinity, we're shading all the way to the right. And guess what? It is an OR compound inequality. Let's write it as an OR compound inequality. We're going to have our variable, one on each side of that OR, and then just focus on this piece. If I was going to write an inequality with this piece, I would have x is less than or equal to -3. Now I'm going to focus on this piece. If I was just going to write an inequality based on that piece, it would be x is greater than 0. All right, number 7. Now, when you get to your homework, you're going to have to convert between the two. So drawing a number line may be helpful, but it is not necessary. It's just kind of how do you process. So I think the number line is helpful when we're doing this. We're looking at endpoints. All right, x is less than, so open circle at negative 11, less than is shaded to the left. X is greater than negative 4, so open circle shaded to the right. All right, so that means we're going from negative infinity all the way up to negative 11. We're going to join that with negative 4 all the way out to positive infinity. So that is kind of how I write these. I do a lot of talking to myself when I am working problems sometimes, but I pretty much go straight through, and that's how I've learned how to read it. Negative infinity is out here all the way up to negative 11, and then jump over, union that with negative 4 all the way out to positive infinity. All right, it looks like this is 29 and this is 30. It's a little fuzzy where I am, but it looks like we're shading this way and this way. So we have another OR, compound inequality. I'm going to go do my interval notation because I really want you to be practicing that. So for the left, we're going all the way from negative infinity to 29. I think those are open circles. Yeah, they look like open circles. But if you made closed circles, that's okay. Closed circle, you would have a bracket. Join that with 30 all the way up to positive infinity. And then again, you're looking at an OR, compound inequality. X is less than 29 or x is greater than 30. How's it going? Doing okay? Lots of new stuff. Hopefully it's not too confusing. If it is confusing, you need to let me know so I can help you out. I'm going to stop you right here. That's it for the lesson. See you in the next video.